Episode 1. The James Webb Space Telescope. A History of Optics. While deep space telescopes are an amazing feat of technology, they do come with some issues, especially depending on where they tend to reside in space. Hi there, my name's Coralie, and if you've fallen this far down the internet rabbit hole, go touch some grass. If you're here on purpose, welcome to Space Nerds. Earlier this year, I had the chance to write a chemistry research paper on any element of the periodic table and how it helps us solve a problem in our day-to-day lives. I chose beryllium, but more specifically the beryllium within the James Webb Space Telescope's mirrors. And while I was incredibly proud of the results at the time, I don't feel I did the topic justice, so I wanted to take the opportunity to revisit it today. In our day and age, there are two widely known and important space telescopes that form a part of our scientific environment: the James Webb Space Telescope and the Hubble Telescope. While both telescopes are still currently in service, the JWST is widely considered to be Hubble's successor. The two telescopes have lots of differences in a lot of different technical fields. The main ones we will be focusing on today is their respective optics, their mirrors. The differences between the two telescopes stem from many different reasons. The differences between their mirrors specifically come from different uses and locations the telescope reside in. The Hubble telescope resides in a low Earth orbit, or LEO, at an altitude of about 515 kilometers. While it is still considered a deep space telescope as it observes deep space, the telescope itself does not reside in deep space. Hubble is not a large telescope, with its primary mirror only measuring 2.4 meters in diameter, made of high silicone ultra-low expansion glass, and coated with thin layers of aluminum and magnesium fluoride, which basically means the mirrors are a layer of glass that change very little in size when exposed to harsh temperatures, and are coated with a thin layer of aluminum and magnesium fluoride, which is an element with anti-reflective properties. On the other hand, the James Webb resides in an orbit around the second Lagrange point, L2, one of the 5 points in our solar system where the gravities of two different bodies of mass equal out. The JWST can be found around 1.5 kilometers away from home and resides in deep space. This causes a number of issues when designing such a telescope. Primarily, the mirrors previously used in the Hubble telescope would not survive the harsh conditions of L2 and would be far too heavy to be able to launch a telescope of the size of the James Webb. Experts started looking into different solutions and eventually settled on foldable gold-coated beryllium mirrors, leaving us with the iconic gold hexagonal primary mirror the James Webb is so well known for. Using beryllium to make mirrors instead of aluminum and glass presents many different advantages, mainly weight and temperature-wise. The telescope's primary mirror measures a whopping 6.5 meters in diameter, and itself is made up of 18 different hexagonal mirror segments. The shape of these mirror segments is the reason the images produced by the James Webb have 8 diffraction spikes compared to the Hubble's 4. Beryllium is a very light and strong element that becomes extremely stable once cold enough, which is why it was used in all 3 of the JWST's mirrors. The process of creating these mirrors is a long and dangerous one. Beryllium, being a rare and low-quality ore with a long list of health concerns for the people who inhale or come in contact with it, is extremely hard to get a hold of. Once mined, beryllium powder is compressed into mirror blanks, then polished and coated with thin layers of gold to maximize reflectivity to low wavelengths. The mirrors themselves were polished and treated at room temperature, but because of beryllium's properties, the engineers working on the James Webb had to take into account the changes in size and calibration that would happen in space to ensure the focus would be just right when Webb arrived at its final destination. While the James Webb and Hubble have a lot of things in common, they also have a lot of differences, especially in the way they both see space. Both telescopes are an incredible part of our scientific environment and have both helped scientists in all fields of space science make brilliant new discoveries, and we will continue to do so with the help of the space and ground telescopes, hopefully for decades to come. And that's it for the first proper episode of Space Nerds. Stay curious, keep dreaming, and thanks for listening to my rant.